Welcome to the DIY Honda Garage channel. The DTC P0107 indicates a problem with the manifold absolute pressure sensor circuit, specifically a low voltage reading. The MAP sensor plays a crucial role in measuring the density of the intake air, which allows the engine control unit, ECU, to calculate the air-fuel ratio for optimal engine performance. This sensor is typically located on the intake manifold close to the throttle body. A malfunction can lead to various engine performance issues, including poor fuel economy and increased emissions. When this DTC is triggered, it's vital to diagnose and repair the underlying issue to ensure the vehicle runs efficiently. Additionally, it's essential to record all freeze frame data and onboard snapshots before engaging in troubleshooting, as this information can aid in identifying the problem. Following each diagnostic step methodically is also crucial for an accurate repair outcome. To verify the repairs for DTC P0107, begin the final verification process by powering down the ignition and reconnecting all previously disconnected connectors to ensure that everything is secure. Upon reconnection, exit any SCS modes using the HDS, turning the ignition switch back to the on position. The PCM should then be reset with the HDS, which clears any stored fault codes and prepares the system for normal operation. Following this, conduct the PCM idle learn procedure to calibrate the engine's idle parameters. After completing these steps, check again for any pending or confirmed DTCs with the HDS. A successful end to this process is indicated if no DTCs reappear, confirming the effectiveness of the repair. Preventive maintenance is essential to avoid recurrent issues with DTC P0107. Regularly checking the connectors and ensuring they are clean and securely attached can prevent poor connections that lead to sensor malfunctions. Inspecting the wiring insulation is also crucial, as deterioration may lead to shorts or breaks that affect sensor readings. Maintain an updated PCM software version to improve communication and functionality of the sensor system. Additionally, routinely test the performance of the MAP sensor under various operating conditions to ensure reliable output. By taking these preventative measures, vehicle owners can help ensure efficient and reliable operation of their Honda Accord's engine management system. In conclusion, DTC P0107 indicates an underlying issue with the MAP sensor circuit, primarily characterized by low voltage. Recognizing the pivotal role the MAP sensor plays in engine management, its malfunction can significantly impact vehicle performance. The troubleshooting steps outlined, from initial verification through to final repair verification, provide a structured way to isolate and remedy the issue. Each step emphasizes the importance of thorough diagnostics, careful measurement, and systematic testing to pinpoint the exact cause of the problem. Preventive maintenance and routine checks can further ensure the longevity of the vehicle's performance and efficiency, fostering a proactive approach to handling such DTCs. Ultimately, the integrity of the MAP sensor and its circuit is crucial for optimal engine operation. And should any DTC arise, diligent troubleshooting, as outlined, will lead to effective resolutions. The DTC P0107 refers to a low voltage condition in the MAP sensor circuit. The MAP sensor is responsible for providing the ECU with data regarding the intake manifold pressure, which helps in determining the air density and allows for precise fuel delivery to the engine. Located near the intake manifold, it can be challenging to access, but it's crucial for the engine's functioning. If the voltage written by the sensor falls below 0.23 volts, This DTC is triggered, indicating a possible failure in the sensor, wiring, or connections. It is essential to understand the role of each component in the assessment, including the importance of maintaining a healthy voltage range to ensure optimal engine management and performance. Thus, addressing this code promptly is crucial to avoid potential engine performance degradation. Several potential causes can lead to the triggering of DTC P0107. Firstly, a faulty map sensor itself can result in incorrect voltage readings and should be considered one of the prime suspects. Secondly, wiring issues, such as damaged or frayed wires, may lead to a loss of signal or inaccurate readings. Poor connections at the map sensor or the powertrain control module, PCM, can also result in low voltage readings, causing the DTC to be activated. Furthermore, if the PCM has outdated software, it might misinterpret the signals from the map sensor, contributing to the error. Comprehensive diagnosis is necessary to determine the exact cause behind the low voltage condition and ensure effective resolution. Symptoms associated with DTC P0107 can vary, but typically include poor fuel economy due to inefficient air-fuel mixture adjustments by the ECU. Another common symptom is engine stalling, which can occur when the engine does not receive the correct air supply needed for stable operation. Additionally, the driver may notice the check engine light illuminating on the dashboard, signaling that there is a problem requiring immediate attention. Identifying these symptoms early can lead to more effective troubleshooting and faster resolution of the underlying issues, ultimately preventing further complications and ensuring vehicle reliability and efficiency. In the first troubleshooting step for DTC P0107, start by turning the ignition switch to the on position or pressing the engine start-stop button to activate the on mode. Once the ignition is on, utilize the Honda Diagnostics System, HDS, to verify the map sensor's current voltage readings against the established threshold of less than 0.23 volts. If the current conditions match this threshold, it confirms that the failure is indeed duplicated, progressing to the next step. If not, document that it is an intermittent failure, indicating that the system might be functioning correctly or that there might be poor connections or loose terminals at the map sensor or PCM. Regular checks of these connections are crucial as they can often be the source of problems that may not trigger a constant DTC. In this second troubleshooting step, begin by turning the ignition switch to the off position or pressing the engine start-stop button to deactivate the engine. Following this, disconnect the map sensor's 3P connector to isolate it from the circuit. Next, turn the ignition back to the on position again. Use the HDS once more to evaluate the map sensor voltage readings. Confirm whether the current readings are still below 0.23 volts. A yes response indicates the problem lies elsewhere, and you can proceed to step 5. A no response suggests further exploration into the map sensor itself or associated circuit, which will be addressed in the subsequent troubleshooting step. Keeping track of each step's outcome is essential in narrowing down the fault. In this next step, measure the voltage between test points 1 and 2, which correspond to specific pins on the map sensor connector. First, ensure that the ignition is set to the on position without the map sensor connected, which creates the right conditions for testing. You will specifically measure across test point 1 at pin number 1, green, and test point 2 at pin number 3, PNK. The expected voltage reading should be around 5.0 volts. If this measurement is satisfied, it signifies the wiring and connections are likely intact, so it is appropriate to replace the map sensor. If not, you would transition to inspecting for any open wire conditions in the next troubleshooting step, which may be affecting the sensor's performance and reactivity. During this step, first, turn the ignition switch to the off position to ensure that no voltage is present while making connections. Once assured, use the HDS to jump the SCS line, setting it to short. Next, disconnect the PCM connector C51P to isolate that part of the circuit. Continuity checks will be performed by examining the VCC1 wiring between the MAP sensor's connector, pin number 3/PNK, and pin number 41/PNK on the disconnected PCM connector. If continuity is affirmed, it suggests that the VCC1 wire is operationally sound, leading to the next potential step of updating the PCM software or verifying with a known good PCM. Alternatively, if continuity fails, this indicates an open circuit in the wiring that must be repaired to ensure proper functionality of the MAP sensor. In this step, confirm that the ignition is still set to off and jump the SCS line in the HDS mode to initiate a short condition. Next, disconnect the PCM connector C51P and prepare to check for shorts in the PB wire leading from the MAP sensor to ground. Measure continuity between test point 1 at the MAP sensor's pin number 2, PUR, and body ground. A successful continuity check would indicate that the PB wire has a short circuit that needs remedial action. If continuity fails, this suggests the PB wire is intact. In such a case, consider updating the PCM software or substituting it with a known good component. This step ensures all wiring and circuit paths are confirmed before concluding any repairs on the MAP sensor itself. Please like and subscribe to the channel. See you next time.